Good afternoon, everyone. First of all, let me introduce myself. My name is Holidia Masburo. I am doctoral program in Institut Teknologi Bandung, and Mr. Hendrawan as my promoter. Today, I would like to present our research entitled Development of Learning-Based End-to-End Video Compression Methods. The outline start from research background, video compression architecture, problem formulation, research goal, literature review, and conclusion. First, about the research background. The research background start from the technology development in the cellular like 5G, and the development of the so many equipment that basis on the IoT. And the second, the video compression development standard like H.265 or MPEG-5 as we known as HEVC. And the third is the machine learning trend research nowadays, and video itself is kind of the information that has a big volume. So during the transmission, we need a large bandwidth, and also the video is having a problem in delay sensitivity. And also we know that several kind of the transmission device are limited in capacity. And the second, based on the annual report from the Cisco, that internet user growth 10% from 2018 to 2023, we can say there is a much annual internet user in Asia Pacific or APEC. And some of the literature cite that 80% of the total traffic using video. And next is the video compression application, such as for security, medicine, digital contents, and on OTT, video conferencing, smart city, online education, social media, online streaming, monitoring system, multidisciplinary. And the second, about the video analytic use case for smart home, retail business, autonomous cars, smart cities, media, security, and surveillance. Next is why need compression. There is an example about the movies that have a size to 720 and 480 per frame, 30 frames per second, and 24 bit per pixel. And the movie consists of three components, or we known as RGB. If we calculate all the numbers, we can get 243 megabit per second as a raw video. And if we want to storage this video into a DVD, we need 5 megabit per second, and this means that the compression ratio 48 to 1. And the second, about the bitrate capacity of the transmission media, like for example the terrestrial TV broadcasting channel, the capacity about 20 megabit per second, Ethernet and or fast Ethernet less than 10 to 100 megabit per second. For wireless cellular data like 2G for 64 kilobit per second, 3G or HSPA plus 8 megabit per second, 4G LTE 50 megabit per second. And next is about video compression architecture. First, I wanted to explain about video compression evolution. Start in 1994, the standard MPEG-2 and in 1999 MPEG-4 audio video coding at 2003, and HEVC invented at 2012. And how about the future video coding? And I also want to explain about the difference or the comparison between MPEG-4 and H.264. For the example, the block size for MPEG-4 16 to 16 or 18 to 80 in MPEG-4 and 16 to 16 or 4 to 4 in H.264. Next is about hybrid motion compensated video encoding. There is a video process from processor become a bit stream, then sent through multiplexing. That's by using several kind of pipes, for example inter or intranet, wireless network, AX, XDSL, cable, satellite, and so on. The important part here is called motion estimation or and motion compensation. Next is about hybrid motion compensated video decoding. There is the opposite process from the encoding. We can see from the demodulator demultiplexing, we can get the bit stream, then through the process we can get the video information. And next is about MPEG-4 or H.263 video coding block diagram. We can see the several process from the input video to the compressed video. As we know, the important part here is motion estimation. This part having a this part responsible for determining the current frame from the information of the video in previous and the next frame. Okay, next the tradition and end-to-end video compressed with machine learning. The important part here is about the calculating loss. The calculating loss which is done end to end. And next, about the development of video compression, we can conclude that based on the theory, we know the compression theory such as of information theory such as Shannon-Fano, Huffman arithmetic, binary arithmetic, block-based coding, transformation coding or DCT, predictive coding, and so on. And the present we know the many kind of the standard of the video compression like H.265 or known as HEVC or MPEG-5, and the future the compression video compression machine learning based. We can conclude that. Next is the about the problem, the former problem that we find in the video compression research, that there is the graph that explain about the former standard of the video compression called HEVC, that we know that the bit rate is decrease for so many several kind of the standard, and the PSNR is higher or increase. That's mean that the compression nowadays for the HEVC having a low bit rate and also have a high quality. It shows based on the PSNR value that increase. There's also a challenge for our research now. The next is I wanna show you about the video compression example. There is a original video and the compressed video. We can see that some blurry picture on the compression video. The problem formulation here for our research is the based on the comparison of existing standard video compression with high quality and lower bit rate. So we the opportunity to achieve the compression ratio and computational speed by using machine learning. And research goal, how to propose the video compression technique using machine learning. Okay, next about literature review. Literature based on the literature review that I have been read before, I can make the hierarchy of the video compression learning based method. There is two method based on the conventional learning and the learning based end-to-end. The conventional learning we can we can use several methods such as interprediction in loop filter, and post-processing, learning based guidance of the conventional codec, and learning based end-to-end compression. There is two method: predictive and generative. Predictive, we can use three methods like learning based flow estimation, the motion compensation become warping function, the learning based form synthesis, and generative video coding. We can use autoencoder, autoregressive, and dynamic number of priors. Next is the conclusion. There is four conclusion that I have been made. First, technology advance trigger the development of such coding system for video. Various efficient video compression types are used based on the size of the video and the limitation of the information transmission capacity. ITUT and MPEG were developed with H.264 or MP4 as a video coding standard. H.264 or MP4 has a limitation on the variable block size. A successor to H.264 or MP4 is HEVC. The HEVC coding standard was developed by ITUT and MPEG as well. HEVC has the advantage of variable macro block size compared to H.264 or MP4. Following the current technology developments, along with the development of various platforms such as digital TV, 5G, IoT, and AI, enable such source coding that can communicate with humans and machines. So we need video coding that has this capability. This requirement underlies the development of future video coding based on machine learning. Predictive and video coding constitute end-to-end learning-based video compression category. Predictive coding is a method that has been found to apply to a wide range of applications, as described in previous literature. Meanwhile, generative video compression is still being researched using uh, auto-regression or autoencoder. Moreover, the research employ more than one sensor for an image, which is referred to as multimodal. Because of this, it is possible to do new research with this method in the future. Thank you for your attention, and good afternoon.